Greetings and welcome, friends. My friendliest of friends. Much obliged, much appreciated that you're here today. Yesterday we were talking about reflections, rotations, translations, transformations, dilations of matrices. And we're kind of on like page, looks like 94 or something like that. Here's question 17. It says, use the matrices to determine the coordinates of the vertices of each translated figure. Bam. So let's do that. So it says square CDEF. All right, is translated 3 units right and 4 units up. If the vertices are, let's see, let's make our original vertex matrix. So negative 3, 1, 1, 5, 5, 1, and 1, negative 3. Is that, if that's the location of the original, let's translate this 3 units.
I have a question. What if it's 3 units to the left?
Then those would all be negative 3s.
Oh,
so right is positive.
Yeah, just like right. Yeah, it's related to the coordinate plane. So the positive x-axis is to the right, positive y-axis is up. So I'd be adding 3s all to that row, 4s all to this row. So a translation matrix must be the same size as the original, and each row is composed of elements that are identical, and you merely add in order to find your new matrix. So here I'd have 0, I'd have 4, I'd have 8, I'd have 4, and then I'd have 1 plus 4 is 5, 9, 5, and 1. And then if we wanted, we could graph this. Let's see.
Are we going to have to graph it on the quiz? Oh, God.
I don't think so.
Hey.
Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-ish. Something like that, right? So the pre-image would have been a negative 3 up 1 right there. Over 1 up 5, like there-ish. Actually, it's there. That's fine. Over 5 up 1, let's say it's like there. And over 1 down 3. So let's pretend this is a square for the pre-image.
Diamond.
Oh, it's a square, though. They defined it as a square in the original problem. So that may or may not be true. So let's see. 0, 5. So there's 0 up 5, somewhere like that. Would be that location. Over 4 up 9 would be somewhere like this. Over 8 up 5 would be somewhere like this. Over 4 up 1 would be something like this. And you can see, there's our awesome square, Kirsten. So this is the image, and the green one is the pre-image. The location, the values of these, notice that when they labeled it, they called it C prime, D prime, E prime, F prime. So the image, the end result after some sort of transformation, you can label all of your points with primes in order to symbolize that change. So let's look at another example. Here's 21. A trapezoid with vertices, blah, blah, blah. Let's do this. Negative 1, negative dose, negative 3, 1, negative 1, 5, and 2, 4. So once again, for my vertex matrices, they could have any number of columns depending on the number of points I'm representing, but the number of rows is 2 if I'm working in 2 dimensions. So X is the top row, Y is the secondary row. Now it says we're trying to do a reflection over the line Y equals X. So I multiply on the left. We always multiply on the left by one of our...
So it would be negative 1, 0, 0, 1. Right?
Where are you getting this?
0, 1, 1, 0.
Yeah, I think it's the 0, 1, 1, 0.
0, 1, 1, 0. Yeah, I'm not seeing...
Yep, so reflection over the line Y equals X. Third one down on our little chart.
Yeah.
So, my resultant matrix will be the same dimensions. This was, well, actually, let's do a little dimensional analysis here. Here's a 2 by 2. This is a 2 by 4. The inner numbers match. Hooray! And the answer will be the outer numbers. So that's a 2 by 4.
Can you wait?
No, just follow along. It's fine. It's fine. So let's see. Multiply rows by columns. So 0 times negative 1 is 0. Oh, 1 times negative 2 is minus 2. Next row, or still same row, next column. 0 times negative 3 is 0. 1 times 1 is 1. 0 times negative 1 is 0. Plus 5, and 0 times 2 is 0, plus 1 times 4 is 4.
So you had to do all of the...
Yep.
I'm so confused.
I multiplied each of these columns by the first row, giving me the first row and each of their respective columns answer. So I'm not done yet.
Wait,
So-
why? Can you just show me?
Yeah, multiplying a row by a column.
I know
Gives me the
that.
first row,
So
first
0
column.
minus 1
0 times negative 1.
is 0.
Yep.
And then 1.
Times negative 2. And I add the results.
Yeah.
Yep.
So we do that same thing for all the other ones too.
Yeah, so second row, first column will give me the second row, first column answer. So 1 times negative 1 is negative 1. 0 times negative 2 is 0. This will be negative 3 plus 0. This would be negative 1 plus 0. And this one will be 2 plus 0. So Hank, now that I can simplify this, you might have noticed what it did there. What did it end up doing as an overall effect to our original problem? Yeah, it just switched the x's and the y's is all it did. Which, if you recall back to the previous course when we did finding the inverse of a function, oftentimes what we did was we switched the x and the y's. Whether we were given a set of points or an equation, we would switch the x and the y, and that would find for us our inverse. So my answers are negative 2 comma negative 1. And let's see, what did they originally label these? H, I, J, K. So yeah, so H prime is that, I prime, not to be confused with the imaginary number. J prime is 5, negative 1. J prime sounds like a pretty great rap star name. K prime. K prime would be alright too, although if they were a transformer, they wouldn't be as good as Optimus Prime. Am I right? Optimus rhymes pretty good. Hip Hopopotamus, Rhymenoceros. So
That's a legitimate song.
So yeah, it is.
Fly the Conchords.
Oh yeah, Flight of the Conchords represent. Go check out their YouTube channel. I'm sure it's great. Problem 21. That's good. So one of the things I just want to point out is that with our reflection and rotation matrices, you always have to multiply on the left-hand side. Don't multiply it on the right-hand side by that value. That'll done mess you up. Multiplication of matrices is not commutative, and in some cases not even possible. So thanks for watching, internet friends. Have a great day. Bye-bye.